Okay, so in question 1, the important thing that I did here was to put some brackets around the top and bottom of the calculation. You need to make sure that all of this gets divided by all of this, and brackets will help you do that. Type that into your calculator and it will come out as this. Now, in order to round this to two significant figures, you need to cut off after the second significant figure. That's the second important number, which is the 5 here. There's a 5 that comes after the line, so we need to knock this number up by 1, giving us 6.6. 2 marks for this, 1 mark for this. Question 2, the important thing to remember here is that when you're stacking these skips, the first skip in the stack you're going to count the full height for. Every additional skip then you're going to add on an extra 0.3 metres. So when it comes to working out the height of 15 skips, you want the height of the first one in the stack, which is 0.76. And then for the other 14 that you're going to put on top, you just need to count the 0.12 metres. Sticking that into your calculator gives you 2.44. If you wrote down this calculation, that's 1 mark. If you got this answer, that's 2 marks. So going backwards here for part B, if the stack of skips is 3.46 metres high, first thing we're going to need to do is to take off the skip from the bottom that's at full height. So 3.46 take away 1.96 is 1.5. Then we're going to see how many skips there were by dividing by 0.3 to find out how many additional skips have been put on top. 1.25 divided by 0.3 is 5. Don't forget now that you need to add this 5 onto the original one that we've counted here to give you 6 altogether. These two calculations here get you 1 mark, and an answer of 6 gets you the second. Okay, in part C we know that the stack of large skips is the same as the stack of small skips. So we're going to start by working out the height of 9 skips. So we do that as we did before. Start with the stack of 1, which at full height is 1.96. Then we need the other 8 to have another 0.3 on top. That calculation gives us 4.36 metres. Okay, then because we know that the two stacks are the same height, we know that this must be the height of the small skips. So like we did on part B, we're going to work backwards through this. So start by taking off the height of 1 skip, then dividing by the 0.12 to find out how many additional skips there are. It gives us 30, plus the one already counted here, gives us 31. 31 skips in total. 1 mark if you got this calculation, second mark if you got this calculation, third mark for getting an answer of 31. Okay, so in question 3, there's a few different ways around this. I've started by turning 0.75 litres into millilitres. Okay, if you've done conversion for this or changed 500 millilitres into 0.5 litres, you've got yourself a mark straight away. Okay, so what I've said now is I've taken the price and divided by the millilitres. That will tell us how much each millilitre costs. So in pounds for the large one, I've done 2.85 divided by 750. That tells me that each millilitre costs 0.004071428 pounds. Similarly for the small, the 0.00358 per millilitre. I'm looking for the one that is cheapest here, so I'm looking for the one that has the smallest number. This is the small one, so the small is better value for money. Now for your last mark, we need to say, we're going to answer the question, we're going to say which of them is correct. So Liam is correct. Question 4, reverse percentage question. So we know that 10% was taken off, so what we've got here is going to be 90% of the final price. If we turn that into a multiplier of 0.9, 585 divided by 0.9 gives us 650. 4 marks for that question. You get 2 marks for the calculation, and then 2 marks for your final answer, £650. Okay, in question 5. First thing here is just get in your head the route that they're going to take. So he's going to go from A to B, B to C, and then diagonally back from C to A. If you haven't spotted it yet, there's a right angle triangle here, so we're going to need to do some Pythagoras. Let's start with the distance A to B to C. So A to B to C, well, that's just a case of adding 30 plus 40, which was 70. Now to work out the time for that, we're going to do the distance divided by the speed that he runs at. 70 divided by 5 is 14 seconds. So A to B to C, going a long way around, takes 14 seconds. Now in order to work out this distance here, like we said, we're going to need some Pythagoras. C to A, that's going to be 30 squared plus 40 squared. Square root that to give us 50. Similar calculation now, we know that the distance is going to be 50 metres. 50 metres at a speed of 4 metres per second is going to take 12.5 seconds. So in total, 26.5 seconds. So to answer the question, yes, he does win the prize because he has less than 30 seconds. Your marks here, you get a mark for calculating 70 metres. You get a mark for calculating the distance here, 50 metres. In fact, there's 2 marks for that. So 1 mark for this, 2 marks for that. Your next mark comes from doing some calculations. So a mark from the 14 seconds and a mark from the 12.5 seconds. And your final mark comes from answering the question. Yes, who wins the prize? With these calculations gets you the 6th mark. Question 6. Okay, tricky question. I'm going to start by working out the area of the shaded area. It's a bit on the inside. It's a circle, so we're going to need to do pi times the radius squared, pi times by 3 squared. Now for now, because I've seen what's coming up, I'm going to leave this as pi. I'm not going to use this as an exact value. I'm going to leave it as 9 pi. Okay. Same sort of thing for the white. Now for the white area, we're going to start out the area of the whole thing, and then take away the area of the circle from the inside. So the area of the whole circle will be pi times by 6 squared. As we said before, the shaded one was pi times by 3 squared. So this works out as 36 pi, 9 pi, and 36 pi take away 25 pi. Sorry, 9 pi is 25 pi. So now to the ratio that it's asked for, white to the shaded area. Well, we said that this is the wrong way around. That the white area that we found here was 25 pi, and that needs to be to the shaded area of 9 pi. Now because these have both got pi, we can simplify it like we would do anything else. Divide both of these by pi to leave us with 25 to 9. So we get a mark for correctly working out the area of the shaded area from this calculation. We get a mark for this calculation and a mark for this calculation, subtracting. Final mark comes from your ratio.